Welcome back to Flux, our YouTube channel. In today's video, we're going to guide you through the process of using R for data analysis. R is a powerful programming language used for analyzing data and making cool graphs. Whether you're new to R or looking to improve your data analysis skills, we've got you covered. So let's get started. Introduction to R. R is an open-source language that's widely used by scientists and data experts for analyzing data and creating graphs. It's free to use and has a lot of tools for working with data. In this video, we'll show you how to start using R from installation to doing some basic data analysis. Installing R and RStudio. To get started with R, you need to install R and RStudio. RStudio is a program that makes it easier to write and run R code. Follow these steps to get everything set up. All the links are available in the description below. Download R. Go to the website and download R for your computer. The link is in the description below. Once the download is complete, open the installer file. You should see a screen like this. Click Next to start the installation. Choose the default installation path and click Next again. Continue clicking Next until the installation is complete. Download RStudio. Go to the website and download RStudio Desktop. The link is in the description below. After downloading, open the installer file. You should see a screen like this. Click Next to begin the installation. Choose the default installation path and click Next. Keep clicking Next until the installation finishes. Opening RStudio. Once both R and RStudio are installed, open RStudio by double-clicking its icon. Now you're all set to start coding in R. Let's move on to some basic operations you can do in R. Basic operations in R. Let's start with some basic operations in R. These include doing math, creating variables, and working with vectors. All the code snippets used in this video are available in the description below as a Microsoft Word file. Arithmetic operations. R can do basic math like addition, subtraction, multiplication, and division. Here's how you do it. This adds 5 and 3 and stores the result 8 in a variable called add. This subtracts 3 from 5 and stores the result 2 in a variable called sub. This multiplies 5 by 3 and stores the result 15 in a variable called mul. This divides 5 by 3 and stores the result approximately 1.67 in a variable called div. Creating variables. You can store values in variables to use them later. This stores the number 10 in a variable called x. This stores the number 20 in a variable called y. Vectors. Vectors are like lists that hold elements of the same type. Here's how to create a vector. This creates a vector called myVector with the numbers 1, 2, 3, 4, and 5. The C function stands for combine, and it combines these numbers into a single vector. Loading data. Next, we'll load some data into R. You can create data tables called data frames manually or load data from files like CSVs. Creating a data frame. A data frame is like a table with rows and columns. Here's an example. In this code, we create a data frame called df with 3 columns, name, age, and salary, and fill them with data. The data.frame function creates the table, and the C function combines the values into vectors for each column. Loading data from a CSV file. You can load data from a CSV file using read.csv. This code loads data from a file called yourfile.csv into a variable called myData. Make sure to replace the path with the actual path to your CSV file. Data manipulation with dplyr. If you haven't installed dplyr yet, run this command. Code installs the dplyr package from the internet. The dplyr package is essential for data manipulation in R. It provides a set of functions to perform common data manipulation tasks. If you encounter any issues installing dplyr, make sure to check your internet connection and try running RStudio as an administrator. Selecting columns. Use the select function to choose specific columns. This code loads the dplyr package and selects only the name and age columns from the data frame df. Storing the result in selected underscore data. Filtering rows. Use the filter function to filter rows based on conditions. This code filters the rows in df where age is greater than 24 and stores the result in filtered data. Creating new variables. Use the mutate function to create new variables. This code adds a new column called age in 10 years to the data frame df, which is the age column plus 10. Summarizing data. Use the summarize function to get summary statistics. This code calculates the average salary from the salary column and stores the result in summary data. Grouping data. Use the group by function to group data by a variable. This code groups the data by name and calculates the total salary for each name, storing the result in group data. The symbol is called the pipe operator and is used to pass the result of one function to the next. Data visualization with ggplot2. The ggplot2 package is a powerful tool for creating graphics in R. Here are a few examples of common plots. Scatter plot. A scatter plot to show the relationship between two variables. This code loads the ggplot2 package and creates a scatter plot with age on the x-axis and salary on the y-axis. The as function is used to specify the variables for the axes, and geomPoint adds the points to the plot. Bar plot. A bar plot to show the distribution of a categorical variable. This code creates a bar plot with name on the x-axis and salary on the y-axis. The stat identity part tells gplot2 to use the actual values of salary for the bar heights. Histogram. A histogram to show the distribution of a numerical variable. This code creates a histogram of the age column. A histogram shows how often different values of age appear in the data. The bin width 1 part sets the width of the bins to 1 year. Box plot. A box plot to show the distribution of a numerical variable across categories. This code creates a box plot with name on the x-axis and salary on the y-axis. A box plot shows the distribution of salary for each name. It displays the median, quartiles, and outliers. Performing statistical analysis is also excellent for performing statistical analysis. Here are examples of linear regression and a t-test. Linear regression. This code fits a linear model with salary as the response variable and age as the predictor variable, and then shows a t-test. This code performs a t-test to check if the average salary is different from 60,000. The result is stored in t-test. Saving and sharing your work. Finally, you can save your plots and data to share with others. Use the gsave function to save your plots. This code saves the last plot you created to a file called myplot.png. Saving data. This code saves the data frame df to a file called mydata.csv. There you have it, a comprehensive guide on how to use R for data analysis. By following these steps and using the provided code snippets, you'll be well on your way to mastering data analysis with R. Remember to check the video description for the code snippets used in this video. If you found this video helpful, don't forget to like, subscribe, and hit that bell icon to stay updated with the latest tech tips from Flux. Thanks for watching, and we'll see you in the next video. Until next time, good luck and peace.